Another time, I have to admit, there were two, probably three times, there was a triangular thing in the sky where there were lights on the vertices, and there was some residual light in the Norwegian summer sky. So it was I was able to see with my binocular there was a body, a triangular body.
Hello everyone, welcome to Star Views. Today it's a great pleasure to be here with Professor Massimo Teodorani. Professor Teodorani is an astrophysicist. He has a degree in astronomy from the University of Bologna and a PhD in stellar physics. He is also a research affiliate with the new Galileo project led by Professor Avi Loeb that we interviewed recently on this channel. Also, Professor Teodorani has been involved in different studies about ET life and UFO search with the Helstalen light and the SETI, the search for extraterrestrial intelligence. So, Professor Teodorani, welcome and thank you very much for your time.
Thank you for having me here, and you can start with your questions.
Sure. I want to start from the beginning because you were already involved in this kind of projects to approach the UFO hunting, so to speak, with a scientific method, a scientific approach. One of them is the Helstalen Lights project. Sorry?
Helstalen.
Helstalen. So Helstalen is a place, a site in Norway, correct? Where there is this light phenomena that has been very peculiar, and there is a group of scientists that has been studying it for years. And some claim that maybe there were what we call now UAP, unidentified aerial phenomena, but I let Professor Teodorani to talk about Helstalen.
Yeah. There is a story behind that. It was just after earning my PhD many years ago. I was in a free market outside and I found a by chance book which was named Science and the UFOs by Jenny Randles. And the book fell on my feet and it opened on a page where it was written Project Helstalen. And so I started to think, according to my technical experience in astronomical observations using several kind of telescopes, several wavelengths, I told myself, well, why not using the same technique in order to try to get the same physics data from this light phenomena, because after all, it's just the same physics. So I thought that we can obtain the same information with the so-called UAPs, which is the more politically correct term for UFOs, which is not a more invasion. The bad news is that UAPs are not objects with fixed coordinates like stars that are far away. Every time you put on a computer the coordinates and you find the stars there in the center of your eyepiece. But in the case of your UAPs, this doesn't happen.
Professor, can you actually describe, in fact, what happened in Helstalen that attracted the attention of the scientists?
The story started in 1981 when there was a so-called flap. Flap is a ufological term to say that all of a sudden this kind of lights appear. In 1994, again, it happened. And Professor Erling Strand of the Østfold College decided pragmatically to apply the method, a method that is very similar to my one. He's an engineer and he used several electromagnetic instruments and to try to measure the phenomena. And he found something. I reanalyzed his data and the confirmation that there was something very important that was going on. Normally, there are different kind of phenomena. The most common is made of a sort of light balls that are floating in the air which are sometimes blinking. Most often they are blinking, and sometimes they move in a very, how to say, smooth movement, and sometimes they have a jerking movement like a random, erratic, which is difficult to track if we have instruments. They can change colors. Sometimes there is another kind of phenomenon, which we at Wingstrand called flashes in the sky. There are some kind of sudden flash in the sky that it's something like if a light bulb is about to be born, but it tries, but then it vanishes immediately. In other cases, the light balls are formed and they they can last a very long time, up to 2 hours, while they turn on and off all the time. And when they are off optically, they can be visible if you use a night vision system with an image intensifier, and in case if we have also infrared.
Basically, you have these light balls, if I understand, in the sky. They are appearing. Sometimes they even stay there for more than 2 hours. They travel very fast, and they are very hot, if I understand correctly also. And the temperature of these light balls is constant, which is something unusual for a natural phenomenon.
Yes, what I found, at least putting the numbers in a chart, which is published on my technical paper. Apparently, they are plasmas, but we didn't, in Esdalen, we didn't observe using spectroscopy. In other places, for instance, close to where we live, in Veneto, Jerry Ercolini, who is a very skilled observer, was able to take a spectra of similar light phenomena. And I analyzed the spectrum. It was very clear. This phenomenon is identical to the Esdalen. In this case, we were able to see very clearly the spectral lines, emission lines of oxygen. So in this case, this means that you have a very, hot plasma, which is exciting the molecules of the atmosphere and make so that the atoms make quantum jumps, and the electrons don't leave the atom, but they jump to a higher quantum level, and when they jump down, they create the effect that we see, that are spectral lines, and only a plasma, a hot thing, can create that. Okay.
Is it true that they also travel? Also, they travel very fast, but also they travel in kind of formation, and the distance between them is constant, which is something very unusual for natural phenomena?
Yes, you read about that case, because in Esdalen you can have fundamentally 3 kinds of phenomena. The most common is the light balls, and the other one are the flash in the sky, and the third is the less common, but the most astonishing, is something that looks like to be structure, because the lights maintain the same distance from each other, like if they are attached to a solid body.
About that, Professor, I read that actually 95% of these lights that you have seen and you measured with instruments, they were plasma formations. But the 5% of these lights were actually solid-like objects. Can you tell us a little bit more about this?
If we measure the way in which the light varies from the peripheral area of a light bulb to the center, you obtain a Gaussian curve. Okay. In this case, the curve is very steep, is steeper than from a normal plasma. What is most astonishing is that there was, in one case, a group of 3 lights that were very close to the ground, one of which started to change shape from an amorphous plasma-like ball to a perfect rectangle a rectangular light. And in this case, a person would say, well, this is a pixelation effect. It was not, because inside they were not inside the light. We measured the frame. There were not 4 pixels. There were 400 pixels. Okay, so it's real, and interesting that the same kind of phenomenon was seen not only with a professional video camera, but also with an exposure using a conventional camera, at that time a film camera. It was showing the same, but it was more smooth because something was going around that.
So you're saying that there was this light, an amorphous, that didn't have a particular shape, that took a shape of a rectangular.
Yes.
A rectangle. Okay. Yeah. But Professor, do you, of course, like the goal of this project was to measure this phenomena with optical and other kind of instruments, scientific instruments. But did you happen to you to actually witness personally?
I did. There, when I was in Stalin, I witnessed together with my assistant this transformation of that light into a rectangle, but I had to be precise. By using by naked eye, it was not very easy to see because it was quite far away, somewhere something like 3 or 2 kilometers, but very luminous. We could see it when we analyzed the video, where all of a sudden you had that.
But you are not there by yourself. You were there with other colleagues of yours.
I was there with other colleagues, yes.
So there were more than one witness.
Yes, there were also some journalists from Italy, but I don't remember if they have seen us while we were looking in depth to this video. The strangest thing was that it was real, because at the same time I launched an exposure with my camera, which showed a same shape, but in a very smooth way. Yes.
And of course, because you are a scientist, you need scientific data in order to prove something. So you need evidence, and so like eyewitness don't count towards proving something. Was this the only episode that you actually saw a UFO, or there were other episodes that happened to you personally?
Yeah, first, before telling the others, which were very few, by the way, the fact that we had a rectangular thing has been fantasized by people, telling, oh, this is a portal from a dimension to another or something. Also because around there, sometimes there were light balls all around this. So people have started to fantasize. I think I should behave more like a man in black than as a person who is speaking too much about people, because people can misinterpret my words, okay? Another time, I have to admit, there were probably 3 times, there was a triangular thing in the sky where there were lights on the vertices, and there was some residual light in the Norwegian summer sky. So it was I was able to see with my binocular there was a body, a triangular body, and yet this is not sufficient to tell that this is alien spaceship.
Extraterrestrial.
It could have been a military experiment from somewhere, because this is a very lonely area. So I wouldn't worry. I wouldn't wonder that some NATO military, there is a NATO air base not far from there, might have been doing experiments on that. Another time, 4 days later, it was in August 2000, so 21 years ago, I was with 2 colleagues there. All of a sudden, we have very little light, because there are several dimensions. Very little that can be like ball lightning, practically, up to 30 meters. Okay, that one was very small. I could measure it. It was 40 centimeter. It was elliptical, flattened. This light passed over our head and stopped at height 180, 90 meters away from us, and hovered there for more than 10 minutes. Okay. That one was different from the other kind of light. It was some kind of a translucent and low luminosity, because normally Stalin lights are very luminous. In one case, I was finally able to measure, it was 20 kilowatt, so it was something like 10 times more than a flashlight of a search and rescue helicopter, just to have a comparison. That thing that we saw was weakly luminous, orange, reddish, and clearly structured. And it reminded me some kind of a giant firefly. That was the first thing that came to my mind. I was able to take a photo of that, but I was not able to put a diffraction grating for spectroscopy because my colleague told, please jump into the car. Let's go away from here. It can be dangerous. You are unconscious what you're doing. The point is that in those moments, I am cold, literally cold, only committed to.
Why was he afraid? Why? Sorry if I interrupt you, but why was your colleague afraid?
I don't know.
He was a trained scientist.
Oh, yeah, he was a very trained scientist and one very competent. But I think everyone could be afraid. I didn't feel this fear, and I tried to approach halfway with a camera tripod, simple camera. I was able to take a photo, and you can see it's a flattened ellipsoid.
One question about these lights. Is it true that they also were able to actually emit a light beam or laser beam or something like that? And was it a kind of weapon or?
Yeah, this is very interesting because I was discussing with a German computer scientist who is also a mountaineer who wrote a book about the Dyatlov Pass incident in 1959, if you will remember. In that case, in that area, people saw lights that were emitting beams, just laser-like beams. This same effect was observed, I would say 25 years later in Brazil, in Colares. And in this case, these beams wounded people and in some cases also killed people. This didn't happen in Esdale, but this happened elsewhere in the world. And I recently did a qualitative model on how this could happen, not thinking about aliens shooting with a space pistol or something, but like a natural phenomenon. For instance, if you have a light bulb, which has a very strong magnetic field in it, okay, when this bulb collapses, okay, the rotation starts to increase and the magnetic field is amplified, okay? The magnetic field works like a cage, a containment cage of the plasma. That's the reason probably why these lights never vanish, but they are self-contained. It can happen that if there is a magnetic field and there is a strong rotation, there are two scenarios. One scenario is that when the energy has become too high, the hydrostatic balance is broken. And when it's broken, you have a blast, you have an explosion, okay? And this happened with ball light. But it can happen that in some other cases, there is like a channel where the energy is emitted in the poles, okay? So you could have a beam of light in the north and in the southern pole of this phenomenon in a very similar way than the one that is happening in pulsars, some kind of neutron stars. Yeah, neutron stars that are quickly spinning, and they are emitting high energy particles from the poles. So,
Professor,
yeah.
no, I'm sorry, about this is very interesting. I was thinking, how is it possible that if these balls that are plasma balls that are generated by atmospheric electric sources, that they could last more than 2 hours with that kind of energy?
That's a very good question. And that's the main reason why we are studying this phenomenon, because
Sure.
If you we know that not just from the atmosphere, maybe the atmosphere had its own role, but mostly the ground, when you have tectonic stress, when you have particular minerals like quartz, for instance, basalt or other particular minerals, they stress together and they created the so-called piezoelectric effect, which liberates electric energy in the air so that the air become ionized. Okay, what we should see would be a very amorphous luminescence in the sky, which has been seen effectively some days before and some days after an earthquake, where there is a very strong tectonic stress during those moments. But the mystery is why all of a sudden these lights become self-contained, perfectly spherical, or sometimes they have also other shapes. I mentioned the rectangle. They could be elongated. They could be something like that. We don't know what is keeping the plasma inside, because the plasma would tend to expand, and this would create cooling up to the total vanishing of the
But the temperature remains constant, which is the actual mystery.
From my graphs, yes, I found that. We have to do again many times.
Study more. So basically, 90% of these events are plasma. We know this, but we need to study more because it's not clear yet how this phenomenon is produced. I also read something in your articles about plasma life form. I'm not sure I understood correctly what it is. I ask you if you can give us in simple words what is that about?
I started to elaborate a speculation. So it's not a theory. It's speculation, an hypothesis, which is logical. In 2007, a group of German and Russian physicists found that when plasma interacts with dust, in particular situation, plasmas start to behave like the DNA. So they create helical formations and also are able to self-replicate. This was experimented in a lab already in the old Russian space station, Mir, and then computer simulated by this group of scientists. This is very shocking because it looks like if these plasmas are life forms. They behave like life forms. Putting this together with other evidences, one is that the plasmas behave like a cooperative, in particular whole. And this was David Bohm's studies of plasmas, because his PhD thesis. He found that if you do something to part of a gas, like a nebula in space, all of the rest at any distance will react apparently like if it were only a single hole. There are some, this is not my field, but there are some works that show so-called plasmons, situation in which plasmas can have some kind of possible entanglement inside a structure, quantum coherence.
This is the title of your book, Entanglement, right?
Yes, but in this case, yes. In this case, you have entanglement when you have, for instance, most simple example, two particles that interacted at least once. If you separate one, both of them, you keep one in the lab and the other one goes to Alpha Centauri. If you observe the one on the lab, you alter the spin, and due to the law of conservation of spin, the other particles must react at the same time, simultaneously. So this is very spooky action at distance that surprised Einstein and Podolsky and Rosen. And from that time on, this spooky phenomenon is being found. I suspect that some kind of entanglement inside the plasma is possible.
We learned that.
Yeah.
Sorry.
I'm very fast. Putting together this part with the DNA plasma part with the theory of consciousness of Roger Penrose and Stuart Emmerich about how consciousness works in the brain. If you put together this thing and you say, well, is this happening also in plasmas? So life, possibility of life, possibility of consciousness, this is only a speculation now, okay? Not a theory yet.
You brought up a very interesting point, actually, Professor, because speculation and evidence, these are two parts of science. They are both needed because otherwise we wouldn't move forward. So what is the epistemology here of science, especially in connection with, I was thinking about philosophy and theology, because there, of course, these are disciplines that we cannot have the smoking gun, so to speak. You know, you move forward with speculation. How do you speculate or have evidence about God? It's not possible. So hard science is one thing, philosophy, theology, and blah, blah, blah is another thing. But if you would like to make some consideration about that.
It's a very good and important questions, because this speaks about methodology. If you have a speculation or a hypothesis, if that speculation and hypothesis is logical, is it self-consistent, like we say, you can use it in science because you can test it, but it's not yet a theory at all, okay? But yet, speculations and hypotheses are those who push science forward, because this is the explorative nature of science. So we have to be very courageous, but we have to test them. If we observe, we make a test, and if we see, we get the data that fit our model, our previous model, then the hypothesis speculation becomes a theory. So a theory is something that is mathematically proven. But it can be confuted in the future, because science works by subsequent approximations.
UFOs, extraterrestrial life, multiverse, extra dimension, string theory, landscape, and so on. What is more speculative? Because when I spoke with Avi Loeb in a recent interview on this channel, he said, you know, all these things here are also as speculative because they are not based on evidence. Now, I wanted to ask you also this, I'll let you speak in a second, because I wanted to, you are a research affiliate also for the Project Galileo led by Avi Loeb. I wanted to ask you, how do you see this issue?
Professor Loeb is right. If you take into account, if you consider, for instance, a superstring theory, you have a beautiful mathematical model, so it works very well, but you don't have the data that fit this model. Sometimes we call toy models, okay, very mathematical, beautiful, aesthetical, but we don't have yet, we didn't find yet those particles, which are called superparticles, which would prove this model. So paradoxically, superstring theory is not scientific. Okay, it's a particular situation. It's beautiful what they did, but Avi is right. This is still a speculation, mathematical. Same for the dark matter. We found that the rotation curve of the galaxies is different from what we were expecting from a Keplerian regime, okay? There is something that interacts gravitationally, but that doesn't emit light. So both macrophysicists, astronomers, and microphysicists have been working together trying to find what kind of particles should we find. The point is that neither in space nor in our laboratory we have ever found the evidence of this particle.
But these theories that you just said, they are not scientific. Extra dimensions, you know, string theory, landscape, and so on. But they are not nearly as ridiculed as the search for extraterrestrial life.
Oh no, because it's my vision. Even if I do respect the work of multiverse, like for instance Max Tegmark is making wonderful work. But also all the people of superstring theory of dark matter are doing a very good work in the brain sense of the thing, but it's incomplete, okay? And their work is not ridiculed because they have been building a lot of chairs in the university, a lot of jobs that is based on this kind of research. And I wish them all the best personally, because I am fascinated both by dark matter and multidimensions and superstrings. But they're not completely scientific. That's the point.
Professor, what is going to be your involvement in Avilob's Galileo project?
Well, I am not authorized for now to tell what we are doing now. I can only tell that I was very happy that Professor Loeb involved me inside the group as an affiliate researcher, not in the staff. We have, there is a staff group of Harvard. There is an affiliate group of external researchers like me and many others, all very valid and very well chosen. And there is a group of advisors, among whom there is Dr. Seth Shostak, who is a very skeptical guy. I'm very happy he's there because so, looking at our meetings, you can see what we are doing. We are not fantasizing, we are doing calculus. We are optimizing observations, what kind of telescope, how to use it, how to track it, and numbers, okay? So people who don't like or attack Avi is completely full of prejudice, because if he could peek through the keyhole of our so-secret meetings, they would see that what we are doing is exactly what the research group in astronomy and astrophysics are doing. So we are treating the subject like it out of any emotion, trying to optimize in a very pragmatic way, but clearly we want, a final goal is to obtain a very high definition CCD image of one of these phenomena.
And what is a CCD? Sorry.
A charge coupled device is sort of an electronic camera.
Can we say that your approach here, also that I take from, draw from reading your articles and books, is we need to be extremely, absolutely skeptical, but also absolutely open-minded and curious like kids, because there are so many things we still don't know.
Yes, this is the reason why science was born. If you grow, you cannot be a scientist. You have to continue to ask questions all the time, okay? That's a problem. When we grow, all of a sudden everything is flattened. Apart from the fact that the flattened reality is very boring. But there are many things that are strange, and the goal of science is to try to explain them. Otherwise, it's like to hide dust under carpet. Well, in time, that carpet would become a hill. Okay, so we have to be honest with ourselves and with the others.
Our beliefs don't matter in science because reality is there. But if I ask you something on a personal level, do you believe in extraterrestrial life and in extraterrestrial intelligent life that we can contact?
Yes, yes, I have been working, by the way, in the SETI project. We had a machine which was called Serendip 4, which was a so-called multi-channel spectrum analyzer, which is able to analyze simultaneously 1 billion frequencies, okay? So I've been doing that. We didn't find anything relevant, but there were some transient signals. And the reason why the signals were transient could have been that something might have entered the solar system with a very high proper motion, namely very high angular velocity. My hypothesis was that sometimes something is entering inside the lobe of the antenna of the telescope, and then it goes out because it's too fast. So we have to track it again. And as I told in a congress in 2012, which I also published on peer-reviewed journals, we have to be very attentive, not only to signals, intentional or not, in radio or optical, not only attentive to them, but we have to use our viewfinder. We cannot search randomly in the sky. We never find anything. So we have to find what are the most appropriate stars where to look. The only reason that they show infrared excess, so more infrared than we would expect normally from solar type stars, that can be artificial, coming from the engineering of the circumstellar space by particular advanced civilizations, which could have wrapped their star in some way, so with a lot of infrared radiation.
Professor,
detect it.
Just the last question I wanted to ask you. You are going to bring, of course, in Galileo project your experience from Hasdalen, and the city experience. But are you also going to use some of the data that you collected there at Hasdalen, or you start from scratch with the Galileo project?
No, it start from zero. Yes, I put my experience there, which can be very useful because most of my colleagues don't know how this phenomenon behave, and they must know in detail, and I do, and so that we are able to build up the best strategy using the most adaptive telescope and sensors.
If you can say, when do you think we can have the first data from the Galileo project?
If we are lucky, at least next year, maybe
we can have some data.
Maybe, or some data or some test data, because clearly we have to test with birds, with airplanes, with everything, okay, in order that we know what is the noise, and in order that then we know what is the signal.
Of course.
Yeah.
Professor, this was very, very fascinating, this subject and the experience that you brought to this conversation. So thank you very much. And I encourage everyone to go search for also your books and your scientific articles. And again, I will put everything in the description under the video, and your website, definitely. Professor Teodorani, thank you so much for your time.
Thank you for having me here.
Thank you. I encourage you to like, comment, and share. And till next. Bye.